previous example which we started in the last class, and which was this frame problem. Actually, it was again an indeterminate frame, and we were supposed to analyze this and figure out the reactions. So what we did, actually, we took this D support as redundant, and for that D support, we based on this condition, we wrote this equation, this one. And in this equation, as we also discussed in the last class, that there are 12 unknowns that we need to find out by using the method of deflection, and then we can calculate these three reactions, HD, VD, and MD. Once we have these reactions, then we can calculate the other three reactions, or we can solve this indeterminate frame. So can anyone tell me that what should be our approach to calculate these deflections? Which method should we use? Ibrahim.
Yes sir, virtual work से निकाल लें.
So how can we calculate this FHV, for example?
सर ये तो आपका वो है ना, इसको तो फॉर्मूला से कर लें.
कैसे?
इसका फॉर्मूला इसके लिए आपको चाहिए होगी, एक मिनट, मुझे भी डेल्टा ये तो देखना पड़ेगा सर, इसका फॉर्मूला मुझे दिमाग में नहीं आ रहा.
Okay. This is our primary structure. This was our primary structure. So first thing, obviously, in the moment area method, we do need to have two moments, right? So we do need to write the moment equations. First for the case when all the loads are acting, and second for the case when we apply the unit loads. So in our original structure, this length was 3, 3. This is 96. This is 3, 6. So first we need to have this, have the moment equation. But before that, we also need to divide this frame into different sections, just to based upon the loading condition and the support condition. So how many sections do we need in this frame? Anyone? Usman. 5 section. One over here, let's call this as x1. The other one over here, let's call this as x2. Then the third section over here, let's call this as x3. Fourth one over here, and fifth one over here. So we need to have the moment equation. We will make one table just to make things convenient for ourselves. So this is the portion, origin, limits, and capital M. So if this was our frame, this is point A, this will be point B, this will be point C, this would be point D. Let's call this as point E, and this one as point F. So first portion would be AB based on the section. For example, we are taking section on, sorry, that would be AE. Based on the loading condition, our first section is valid from this point A to this point E, and our origin is A, and limits for this section are again 0 to 3, right? The second section is from B to E. The origin is point B, and again the limits are 0 to 3. The third section will be BF. The origin is B, and limits are again 0 to 3. The fourth section is from C to F. The origin is C, and the limits are 0 to 6. And the final section is from D to C. The origin is D, and the limits are 0 to, this length is 7.5. 7.5, right? So, can you give me the moment equation for this? Or first give me the reactions of this frame. I will draw it over here again. So what will be this reaction? The vertical reaction of this frame.
96.
So the vertical reaction would be 96, and what about this horizontal one?
36.
And third one, this moment. What will be this reaction?
So 396.
Yes. So this moment would be 396. So what will be the moment equation for portion AE or for section 1? What will be our moment equation? Harun, क्या होगी equation?
सर आप क्वेश्चन रिपीट कर सकते हैं प्लीज?
What will be the moment equation for section 1? This is our section 1.
36x1
And
सर एक मिनट.
how many forces do we have at this point A? Anyone else?
Sir.
2 or 3?
Sir, third the moment है ना.
So moment is also a kind of force.
Okay, sir.
36
So-
minus the x1
And
minus 396.
minus 396. So there is a moment as well. So this would be our equation for moment for section 1. What will be the equation for section 2? BE.
सर इसके साथ
हाँ,
-36 x2 लिख देंगे।
क्या लिख देंगे? कैलकुलेट किया आपने? कैलकुलेट किया पेज पे? आलियान, क्या होगी इक्वेशन?
पता नहीं, समझ नहीं आया।
मोमेंट की इक्वेशन क्या होगी? लास्ट क्लास में भी तो हमने किया है। ये बीई सेक्शन है, दिस इज x2, व्हाट विल बी द इक्वेशन ऑफ मोमेंट? जिया,
सर 36x2 -288।
36x2 माइनस, हमारा ओरिजिन बी पॉइंट है।
यस सर।
This would be our frame. This is point B. This is 96. This is 36. This is 396. And then again we have 36. So there won't be any horizontal direction because both of these will cancel out. There will be a
Only
vertical direction of 96. And what will be this moment?
396 होगा।
396. What will be this moment? Anyone else?
सर आप M2 कहाँ पे ले रहे हैं?
मतलब this is portion B to E and
जी सर।
this is x2 and origin is B, which I have written over here.
$180 होगा सर।
180 plus 396,
So 288.
288. Yes. Just resolve there are two forces. This 36 into 6 minus 36 into 3, and the third one is 396. So when you calculate the moment, that would be 288. So what will be the moment equation for portion 2 now? This is section 2.
-36x2 -288.
How 36x2? Our origin is B. For example, if I give you this B on which there is this 288 is acting, I am saying give me the equation of moment from right side. So what will be the equation?
36 into x2 -3 -.
What? अगर वो मैं लेफ्ट साइड से चलूंगा तो ठीक है, वो 36 into 6 होगा, then 36 into 3 भी होगा और 396 भी इंक्लूड होगा। लेकिन अब मैं चल ही राइट साइड से रहा हूँ, तो राइट साइड से तो मेरे पास एक ही फोर्स है, that is 288. So won't it be only -288? My origin is point B. जब आप लेफ्ट साइड से बीम की इक्वेशन लिखते हो तो क्या करते हो? जितनी भी फोर्सेस लेफ्ट साइड पे होती हैं, फॉर एग्जांपल जब हमने सेक्शन 1 में भी लिखी थी तो दैट इज x1, तो लेफ्ट साइड वाली फोर्सेस कंसीडर की थी, राइट साइड वाली तो कोई फोर्स नहीं कंसीडर की थी। क्यों नहीं की थी? क्योंकि हमारा ओरिजिन उस केस में ए पॉइंट था। अब इस केस में अगर ओरिजिन बी पॉइंट है तो मैं राइट साइड वाली सारी फोर्सेस कंसीडर करूंगा, 36 को तो नहीं इन्वॉल्व करूंगा। Now what about section 3? This is section 3 over here. before 96 kilometer. This 96 will go up. Again, we will have 96 over here and 288. So what will be the equation of moment for section 3?
So 288 minus 96x3.
If we follow the same sign convention, it would be 96x3 minus 288, right? And what about section CF? This is section 4. So what will be the equation of moment for this section? Sarah, what will be the equation for section CF?
Sir, 96.
My origin is C.
Sorry.
You can write it other way around, but then you have to change the limits. How much? I can't hear you.
Sir, 576.
I can't hear you.
576 minus 96 x4.
How 576? Have you analyzed the frame? For example, for points or for section CF, it would be convenient for me to start from the right end. I will start solving the frame from right end and then come back to point C. This is point C. This is point D. So there is no force acting on point D. There will be no force that is transferred here or at this point. So at point C, there is no force. So for section C to F, there won't be, the moment will be zero. There won't be any force. There isn't any movement. And even if you start from this end, for example, if you consider this diagram and resolve this frame, you will see that you will get zero force. This 96 will cancel out with this one, and when you solve the moment, you will see that this moment will also cancel out and there will be zero moment at point C. So at point C, we don't have any force and we have to write the moment equation for this particular section, that is x4. So that will be 0. So any confusion about this one? If not, then what will be the equation for section CD? Naveed,
तो वो भी 0 नहीं होगा.
सर CF 0 कैसे आया?
what do you think it should be?
सर आप मुझे आप राइट साइड से कह रहे हैं कि हमने कंसीडर करना है.
We can consider from both sides. The thing is that first we have to figure out that what are the forces that will be acting on point C, right? This is point C. This is 96. And this is also 96. This is 288, right? Just give me a moment. Okay. So what will be the force that is acting at point C? This
सही है
force.
सर, नो फोर्स पे
And what
और
about
कोई है नहीं.
moment?
मूवमेंट नहीं है सर.
Why there is no moment?
सर देयर इज नो फोर्स एंड मतलब आप राइट
ये
साइड से
force
चल
तो
रहे हैं ना, तो
अगर मैं
पॉइंट डी
लेफ्ट
पे तो
साइड
कोई
से चल
कुछ
रहा हूँ, अगर
सर
मैं
वो फिर
लेफ्ट साइड से
कैंसिल
चल
आउट.
रहा हूँ, तब भी वो कैंसिल आउट हो जाएगा.
सर
So try calculating this one. 96 into 9 minus 96 into 3 and minus 288. So what is the moment at this point? That would be 0 when you solve this equation, right? So when I write the equation for section 4, this is my section 4, there is no force, so that moment will be 0. Okay?
सर जब हम इस इक्वेशन को सॉल्व करें तो 0 नहीं आता लेफ्ट साइड से.
Are you sure?
यस सर.
96 into 9 plus 3.
96 into 9 तो नहीं होगा.
That will be 6. Now try solving it. 96 into 9 and 96 into 6.
सर ठीक है सर. 0.
So we have this capital M. Now if you see this one, we do need this delta H, delta V or theta D. For delta DH, for example, if I write the equation for delta DH, that would be, I will write the equation over here. Delta DH, that would be 0 to L into capital M into small m H over EI into dx. Now what is this small mh? This small mh is basically, if this is the frame, then if we apply the unit load of horizontal unit load at this point D and write the equation of movement, that movement equation will be small mh. And similarly for the calculation of delta dv, for example, we would need mv. Now what is mv? mv is basically the this on the same frame, if we apply the unit vertical load, and then in that case the moment equations will be mv. And if we want to calculate, let's say, this alpha v theta, for example, now can anyone tell me what will be the equation for alpha v theta? Hasna, what will be the equation for alpha v theta?
सर इसको हम लोग कैसे जलाना उससे नहीं करेंगे फिर.
फॉर एग्जाम्पल वर्चुअल वर्क मेथड से ही करना है हमने, तो क्या क्या प्रोसीजर होगा हमारा? Anyone who can explain how can we figure out this alpha v theta for this frame? Laiba, can you tell me? Zia,
सर यूनिट मोमेंट लगाएंगे.
can you speak a bit louder?
सर इसका इक्वेशन होगा कैपिटल M स्मॉल
हैं?
सर इंटीग्रल ऑफ कैपिटल M स्मॉल m थीटा dx over EI.
Small m what?
स्मॉल m v थीटा.
Now what is this v theta, small m v theta? मतलब physical मतलब क्या है? कैसे आपने ये calculate करना है? We have done this already in the case for the case of frames.
Unit moment, it's like at point B. Sorry,
Unit
at
moment
point A.
at which point? A?
No, sir, D point, जो right
D
side
point
पे
पे
है.
unit movement. लेकिन हमारे पास
Yes.
इस इक्वेशन में तो दो मोमेंट्स होते हैं, एक कैपिटल एम है और स्मॉल एम है, तो इसमें एक मोमेंट से कैसे कैलकुलेट कर सकते हैं?
Sorry, sir.
So alpha v theta है क्या? First thing is this. If you remember, do I show it somewhere over here? This one. Now alpha v theta is basically this factor, which is the deflection due to when we applied the unit moment on this particular frame, right? So, or this is the deflection, and then we will, when we write this, it would be alpha v theta, or angular flexibility when the unit moment is applied, right? So we need to figure out this factor. So if I have this frame, what will I do? First, I will apply, since it is in the vertical direction, so I will apply the vertical load at this particular point because it is the vertical, or in the first case, firstly I would apply this unit moment as 1, and then I will write the equation of moment. That will be my equation, that will be m theta. Now in the second case, I do need to find this vertical deflection. So what will I do? I will apply the vertical unit load because the deflection is in the vertical direction, and again I will write the equation. Now that equation will be mv. So in this equation, I will replace this capital moment, which is the equation of moment when the original loads are acting. The original load was obviously the moment, and for the case of flexibility, we take the original load as 1, or whichever is the load as 1, and then in the second case we apply the moment in the direction of displacement. So displacement was in vertical direction, so we applied a unit vertical load, and we figured or we wrote the we will write the equation of mv, and that will be, and when we solve this equation we will get factor, this factor alpha v theta. Now on the same grounds, can anyone tell me what will be alpha theta theta? So what will be its the equation for alpha theta theta? Ibrahim, क्या equation हो?
Square theta.
I can't hear you properly.
M square theta.
Yes, it would be m square theta or m theta theta. Or if you look at the frame again, so what is the physical meaning? Physically, it means that initially you need to apply, because this is the angular flexibility when unit load is acting. So initially you will apply this unit movement of 1, and in the second case, since you have to calculate the rotational flexibility, so you will apply this rotational load of 1 and write the equation. Now both of these equations are same, so we can also say that it would be m theta square. And again, if you have to find, let's say, this alpha dv, then what you have to do, since it is also the angular flexibility, so first we will apply this moment of this unit moment, but in the second case we will apply this horizontal load, because this one is V, this DH I am talking about, if you want to calculate DH. So for this DH, you will apply this horizontal load and again write the equation of moment, and you will have this small m theta. And then you will multiply these two factors and take the integral, and you can calculate, you will get alpha DH. So now can anyone tell me what will be this FVH? Hasna.
Alpha DH.
What will be the equation for FVH?
For FPH.
FVH.
एक second, sir. सर ये भी सिंपल m स्क्वायर से नहीं होगा?
What is FVH? First tell me this.
सर जो फ्लेक्सिबिलिटी है, एक सेकंड,
It comes from delta VH, right?
राइट, जो वर्टिकल लोड जो हम लगा रहे हैं उसकी वजह से जो फ्लेक्सिबिलिटी है,
Due to vertical load, the
Yeah,
horizontal
horizontal.
flexibility, right? So first, what will you do? You will apply the vertical load in this direction, or the unit vertical load at this point, and then in the second case, you have to apply the load in the direction of displacement. So displacement is horizontal, so you will apply a horizontal unit load. So due to this one, you will get the equation for MV, and due to this one, you will get the equation for MH. So when you multiply these two factors, you will get FVH, right? So now if you see from all these equations, first you need, for first three factors, you need this capital M. You already have this equation for capital M for all this section. And if you can get the equation for MV, MH, and M theta, then you can solve, or you can calculate all these 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can figure out all these 12 integrals or all these 12 unknown factor. And once you have this, you can solve these equation to get the reaction. For example, for alpha V theta, simply as the sign notation suggests, obviously these sign notation make things convenient for you, but you have to understand yourself that what this means physically. If you don't understand the physical meaning of these notation, you won't be able to get to the actual result. So for example, for alpha V theta, your equation will be MV M theta. For alpha H theta, your equation will be MH M theta, right? So in all these factors, you only need either MV, MH, M theta or capital M. So we have the equation for capital M. Now we will write the equations for MV, MH and M theta, and then we will move on towards the integrals. So any confusion about this one, you can ask me. Later you have to solve this. So first we will, let's write the equation for MV. So for MV, now I'll be very quick about this one because this is the repetition of same procedure. So for MV, you will apply this vertical load of 1 and again write the equation for all the 5 sections. So what will be reaction over here or at this point? A. Can anyone give me the reaction? Class, what would be this reaction?
1.
One.
What will be the horizontal reaction?
0.
And what about movement?
9.
Movement would be 9. So what will be the equation of MV for this section AE. This is E, let's say. This is X1. So what will be MV?
सर 9 ही होगी.
Positive or negative?
Negative.
Suppose
So it would be -9. And then these forces will be transferred. If this is A, this is B, they will be transferred to this point and then over here. So what will be the equation for section BE? This is point E. Class, just be quick. So for section BE, again, it would be -9. And for section BF, which is from this point to this point, our equation will be x minus 9. We have this one as x4 or x3. Let's call this as x3. So this will be x3 minus 9. And for section CF, we again have one force that is acting in the downward direction. So let's call this as minus x. And for section DC, again we don't have any force actually, so it should be 0. So any confusion about this one, just ask me right away. So next case is we have to write the equation for MH. So for that, again the same frame, and we will apply this factor or this unit load of 1 at this point. So what will be the reaction at this point?
sir horizontal 1 होगा, vertical 0.
And moment, don't forget the moment, it is very common mistake.
1.5.
So that will be 1.5. So what will be the equation for section AB? Or section AE? आलियान क्या होगी इसकी इक्वेशन? Daniel, what will be the equation? Are you in class?
Yes, sir.
What will be the equation for section AE?
सर ये मेरे पास ये ड्राइंग फिर फट रही है, क्लियर नहीं है रेजोल्यूशन इंटरनेट की वजह से. एक सेकंड मैं आपको बताता हूँ सर. ये मोमेंट 0 है सर 9 और नहीं सर, नहीं समझ आ रही इसकी.
So again today you will be absent.
सर समझ नहीं आया तो देखते हैं एब्सेंट.
आप पिछले लेक्चर देख के नहीं ना आते.
मैं
सर 7.5 plus x1 नहीं होगा, positive
How
में.
much? This is 1 point.
7.
For section A,
1.5 plus x1.
Sorry,
This is
1.5
1.5.
plus x1.
so the equation will be 1.5 plus x1. Now I'm going to write the equations. I'm not going to solve it. I expect you to solve this now. I have already solved 2 frames for you. So for section 2, that would be 7.5. Is there any question?
Yes, sir.
Yes.
ये 1.5 और x1 दोनों नेगेटिव नहीं होंगे?
Why they should be negative? For example, if I convert this one into a beam, this will be 1 and this will be 1.5 in this direction. So I'm writing the equation for this particular section. So due to 1.5, we have this shape, that is a positive moment. And again, due to 1, the moment is in the clockwise direction, and over here it will be opposite moment. So again, that will be positive, right? If the shape is like this, or bending shape is like sagging, concave up, then it would be negative. If it is concave down, then it would be positive, right?
Yes, sir.
So it doesn't matter if you consider this one as negative, but for that you have to consider, you have to keep the same sign convention for all the moment that you write for this question. So once you select one convention, just proceed with that one for the whole question. So for the third section, the equation would be 7.5, that would be 7.5, and for the last one it would be minus x. And for m theta, you will apply a unit couple at this point, or unit moment at this point. Let's say this is 1, and again solve this whole frame. And once you solve this, you will get minus 1, minus 1, minus 1, minus 1, and plus 1 as your equation. And another variation in this frame, or in the original question, was this moment of inertia. For example, if you see for this in this question, for member AB, the moment of inertia is 2i. For member BC, it is 3i, and for member CD, it was I. So we have to consider this one also when we are solving the integrals. So if I write the moment of inertia for each section, that would be for AE, it is 2i, and this BE is also part of first member, so it will be also 2i. For BF and CF, the moment of inertia is 3i, and for DC it is again I. So now we have all the equation of moment. We just need to substitute these equations into this integral to get these 9 factors. So I will be doing 1 or 2. I'll be solving 1 or 2. Let's start with delta dH. So if I write the equation for delta dH, then how many equations we have? 1, 2, 3, 4, and 5 basically. But for this 4 and 5, this factor is 0, so they will be, by default, they will go up to 0. So we need to write only 3 integrals and we will get this factor dH. So for section AE, the limits are 0 to 3. The moment equation is this one, 36x1 minus 396. And the other factor we need is this MH, and the equation is 1.5 plus x1 for this MH. So if I write over here, that would be 36x1 minus 396 minus 396, and MH for this section is x plus 1.5. I factor is this 2i, so I will write 2ei over here into dx. For section 2, again this capital M is minus 288 and MH is 7.5 minus x1, and limits are 0 to 3 again. So capital M is minus 288, MH is minus x plus 7.5. This EI is 2EI and again dx. And for third section, the limits are again 0 to 3. This factor is 96x 96x3 minus 288. So this is minus, and the third factor is 7.5, and this EI factor is 3EI dx. So what will be this integral?
minus 32,094 over EI.
What?
Minus 3294 over EI.
Minus 3294 over EI. The next one.
सर वो 2997 है सर पहले वाला.
पहले वाला 2997. Anyone else? Did you divide it by 2?
Yes sir.
Sir, 1498.5 over EI.
1498.5. Actually, this is the correct answer. 1498.5. What about second integral? This one.
So minus 2592.
Minus 2592 over here. What about third one?
Minus 1080.
1080. So what is delta DH? And just keep one thing in mind, that there are other two integrals as well, but I didn't write it because they will go up to 0. But in case they are not 0, you have to consider those as well. Anyway, what will be the final answer to delta DH?
So minus 5170.5.
Minus 5170.5 over EI. So this is delta DI. So we have one unknown. We need to get 12. So we have to repeat this process 12 times. Let's calculate another one. Let's go with this alpha VH. So you have an idea how to get the flexibility as well. So for alpha VH, we have 0 to L MV into MH over EI into DX. So from this table, if we see that we have the equations for MV and we have the equations for MH, we simply need to multiply these one and get the integrals to get the final answer. And another thing that this fifth one is 0, so we don't need to consider this. And let's write the equation for other four. minus 9 for first two. So for first section, that would be 0 to 3 minus 9 into minus 1, and EI is 2 EI into dx. For second one, again we have 2 EI 0 to 3, and the factor is minus 9 into minus 1 over, okay, 2 EI into dx. For section 3, we have minus into x plus 9. I think that was, sorry, it is x3 minus 9 into minus 1. X minus 9 into minus 1. The limits are 0 to 3, and the factor is 3 EI. And for the fourth one, again, it would be 0 to 6 minus x into minus 1, and this factor is 3 EI into dx and dx. And the fifth one, the mv is 0, so I'm not writing it over here. So alpha v theta. So what will be this first integral?
$13.5.
13.5. The second one is also same, so it will be 13.5. What will be the third one?
$7.5.
That will be 7.5. And fourth one,
15.
1.5.
how much?
नहीं सर मेरा गलत है. 15.
15.
Sir 6.
How much? 6?
Fi-
What is the
15.
final answer? Give me the final answer. I don't have this separate answer. I have the final answer with me. So I'm not sure what exactly is this one. 15 and someone is saying 6.
So 5.
Final answer is what?
सर 6 के साथ 40.5 है.
40.5 is the correct answer. So I believe it is 6 then. Or you can figure that out, it's just the integration. I'm giving you the final answer as 40.5. So now we have alpha VH, and in the same way, you can calculate all the integrals. Let me give you the final answers for all these integrals. FHH will be 379.125 over EI. Delta DH will be, we already calculated this one. I think it is minus something, so you can see it from there. Alpha H theta will be minus 64.125 over EI. Similarly, delta DV will be 96.57, or in fact 96.57 over EI. FVV will be 324 over EI, alpha v theta we have already calculated, that is 40.5. Alpha theta theta will be 13.5 over EI. Theta d will be 1089 over EI, and FHV will be equal to FVH by Maxwell theorem, and the answer will be minus 222.75 over EI. Are we missing some? How much we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are missing some integrals. Alpha v theta is, okay, let's substitute, then we'll see. So we have all the unknowns that we need for this equation, and if I substitute them back into this one, my final equation will be, I'm going to write it over here. That will be minus 5170.5 over EI plus 379.125 over EI into HD minus 222.75 VD over EI minus 64.125 over EI into MD is equal to 0. This equation 2 will be 9657 over EI minus 222.75 over EI into HD plus 324 over EI into VD plus 40.5 over EI into MD. And the final one will be 1089 over EI minus 64.125 over EI plus 40.5 over EI and plus 13.5 over EI into MD equals to 0. This EI factor will go on to other side and will be 0, because on the other side we don't have any deflection or anything. So now you have 3 equations and 3 unknowns. You can solve these equations simultaneously to get the 3 reactions. And in your calculators, there is an option to solve the equations with 3 unknowns. So you can use that. You don't have to do the whole practice to get the reaction. So if someone can give me these reactions. Or someone knows how to solve these on calculators? Do you know this? Daniel.
सर इक्वेशन मुझे पेपर पे कर सकता हूँ सर, कैलकुलेटर से नहीं आती ये करनी।
करना सीख लो, वरना पेपर में यही करते रहोगे। You don't have this much time to solve this.
Right, sir.
Equation 1 में 64.125 है।
Yes. So if you solve this on your calculators, actually my calculator is a bit different than yours, so it's better that you learn from YouTube or some other thing. You will get how to solve this if you don't know. And the final answers that you will get for HD will be minus 13.75 kilonewton, VD will be minus 33.61 kilonewtons, and MD will be minus 45.13 kilonewton meter. And the minus sign means that the initial directions that we assumed were not correct for all three reactions. For example, initially we considered the horizontal reaction to be acting towards right, the vertical in the downward direction, and movement in this direction or clockwise direction. So the negative sign means that these directions were wrong, and the actual directions are for horizontal the value is 13.75. For vertical it should be upward direction and the value is 33.61, and for movement it is in counterclockwise direction and the value is 45.13 kilonewton meter. And this is 96, 3 meters, 6 meters, 7.5 meters, 36 kilonewton, 3 meter, 3 meter. Now we have three reactions, or we have calculated three reactions, and the next task is to figure out these three reactions that are acting at this number at point A. And once we have these three reactions, we will get we can plot the shear force diagram and bending moment diagram. So I leave it up to you to calculate the reactions at point A and plot the shear force diagram, bending moment diagram, and axial force diagram. So if there is any question about this numerical, you can ask me now. This is it. We won't be calculating these. I am leaving this up to you. So is there any question, confusion, you can ask me.